In this tutorial, we're going to look at failover clustering and how we can set this up in a home lab. Now, for resource purposes, I've managed to get this down to 4 virtual machines. I think this is a minimum required in order for us to get failover clustering up and running, and also for us to see how it works from a client point of view. Now, failover clustering allows us to group nodes or servers together to offer a form of redundancy by ensuring that certain services will be available if one of these nodes or servers goes down. So, for example, if a user is accessing a service on their client machine and the server that hosts this service goes down, then failover clustering should ensure that the service is then passed to another machine, so to ensure that the user can continue to access the service without an issue. Now, I hope that makes sense. If it doesn't, then fear not. This is exactly what we're going to demonstrate with this tutorial, so all will become clear. Now, let's take a quick look at the setup here of our virtual machines and our network. Now, we can see here we've got 4 virtual machines. We've got DC1, which is our domain controller. We've got Clust1, which is the first node in our failover cluster. We've got Clust2, which is the second node in our failover cluster, and we've got our client machine. Now, I've taken some liberties here with regards to this tutorial in the respect that in a production environment, in a live environment, you're more than likely to see 3 or 4 different networks associated with failover clustering. So your nodes would probably have 3 or 4 different network adapters. Now, in this case, for this tutorial, we have 2, and this allows us to get this up and running. So we've got the 10 network, which is our private network, and then we've got the 192 network, which we are using for our cluster network and for our heartbeat. Now, heartbeat in cluster terms basically means that a signal is sent out to all the nodes in the cluster to confirm that they're still operating and still active, and if one of these nodes is down, it doesn't respond, and then the cluster knows that one of the nodes is down, and then it can start shifting the services between the various nodes. Okay, so if we go straight over now to look at our virtual machines, so we can see our 4 virtual machines here. So let's get logged into DC1, our domain controller. Now, just to also note, I've already installed the failover cluster role on both of these, Clust1 and Clust2. So if we go to Tools, let's just get logged into this again. If we go to Tools, we can see that we have the Failover Cluster Manager, and we also have this on Clust2 also. So these are, again, the 2 nodes within our cluster. Again, in a production environment, you would more than likely have more than 2 nodes to offer more redundancy. But again, this allows us to have a look at clustering and get it up and running here. So back over to DC1. So the first thing we're going to do is we're going to sort out our shared storage for this cluster. So on DC1, we're going to open Server Manager, or we're going to try. And with Server Manager open, we're going to wait for all these tiles to load. And we go to File and Storage Services, and we go to ISCSI. So the first thing we want to do is to create a ISCSI virtual disk. So we click here to create a new virtual disk. Oh, of course, we need to install the File and Storage Services role on this server. So we'll do that at this point as well. Okay, apologies. So we now have the File and Storage Services role installed, and we can now create our ISCSI virtual disk. So we go through the process here, we wait for this to load. Now, I'm going to choose the C drive here. Again, in a live environment, you would probably have separate storage for this sort of thing. Let me just move this out of the way. So select our C drive, click on Next, we'll give it a name. So this will be, so we'll call this Shared One, for want of a better idea. Okay, we're going to use a dynamically expanding disk just so we don't use up all of our hard drive. Doesn't really matter, of course, because we're not going to fill any of this with data anyway. We're going to choose a new ISCSI target. We're going to call this Node 1 and Node 2. and now we're going to add both of our nodes. So we have a quick connect button down here. So we're going to connect by IP address. So we're now going to connect our cluster 1 and cluster 2 machines. So just to remind ourselves on the IP address here of cluster 1. So private environment is 10.0.0.2. Right, okay, and for the heartbeat 192.168.1.51. Okay, so this is the one we're looking for because this is our cluster or our heartbeat network. So 192.168.1.51. And click OK. And we're going to add in our second machine now, our second node, which is cluster 2. Okay, and we click next here and configure all the defaults here, and we create our iSCSI virtual disk. Okay, so we're going to create a second virtual disk, second iSCSI virtual disk here, and this is going to be our cluster Quorum. So this is a storage medium in which the whole configuration database is stored for the actual cluster itself. So this Quorum, this basically tells the cluster which servers should be active at any given time. So we need this to complete this configuration. So let's create a new virtual disk here and choose the C drive again. If we can actually see our full screen here. So we'll call this shared 2. And again, dynamically expanding. Choose node 1 and node 2. So this is the iSCSI target we created earlier. Click on next and create. And we now have successfully created the 2 virtual iSCSI disks we need for us to be able to configure the shared storage for our cluster. So what we need to do next is over on cluster 1 and cluster 2 is add these guys as iSCSI targets. So our iSCSI initiator, should I say. So our iSCSI target is DC1, and both cluster 1 and cluster 2 will be iSCSI initiators. So to get this up and running, we click on Tools, and we need to actually start the iSCSI initiator service on both of these. So we're going ahead and do that just now on both. Okay, and we can see here now we have the iSCSI Initiator Properties window. So there's a quick connect button here, and we want to connect this iSCSI Initiator, this cluster 1, to our iSCSI target, which is DC1. So we need the IP address of DC1, which is 192.168.1.50. And we click Quick Connect. Okay, and we do the same on cluster 2. And Quick Connect. And done. Okay, so we have almost completed this configuration. So the next thing we need to do is we need to make sure that both cluster 1 and cluster 2 can actually see this shared storage now. So if we go to Computer Management, and if we scroll down to Disk Management, and we can see now we have a further 2 disks here to connect to, and we should have the same in Clust2. So on both of these servers, we need to bring these disks online and initialize both, and then create volumes within. So bring online, so both online, both now initialized, and on this one we're going to create a new simple volume. And we're going to just stick to the defaults here. It's going to be drive letter E, and we make sure that we give the same volume, or the same drive, the same volume letter on Clust2 as well. So again, if we just confirm all the defaults, we have now formatted this disk, and we're going to do the same with the second one. And I'm going to change this to Q for Quorum, just to keep things right, and again confirm the defaults for the rest. Okay, those both look fine, so we're going to do the same on Clust2 now. As long as Clust2 can see both of these disks. Looking good, so again, bring both online. Oh, need to give this a little minute. That's this now. Okay, so we can now see that we have our two disks online and partitioned. Now we need to keep things universal. We need to change the drive letter here to Q to match with Clust1. Okay, so we have volume E and volume Q, and Clust1 volume E and volume Q. It's very important that we match these together. Okay, so we have now connected both Clust1 and Clust2 to our shared storage for our cluster, and we have also created the relevant volumes within each. So we can go ahead now and configure our actual cluster. So within Clust1, if we go to Tools and then we go to Failover Cluster Manager, the first thing we need to do is validate this configuration. So this is probably the most important part of ensuring that you set up a failover cluster properly. If we click on validate configuration, now this may take a little while to do. At the end, you're hoping that everything is green, there's no errors. If you see any orange errors, then they're not insurmountable. You could possibly still create the cluster with them. If you get any red errors, then there's something amiss in your configuration. So we're going to select our servers that we want in this cluster. So obviously Clust1 and Clust2. So if we put Clust1, Clust2 and add. So Clust1 and Clust2 should both add without issue here. And we click next, and we're going to run all tests. Okay, and we're going to wait for this to complete, and hopefully we will have all green, no errors, and we'll be able to configure our cluster. Okay, so we can see here that the testing has completed successfully, and the configuration is suitable for clustering. Okay, so it takes you straight into the create a cluster wizard. So we're going to call this cluster1. Now we need an IP address for the cluster itself. So what happens is if a client wants to access a service, it sends a request to the cluster IP address rather than to the IP address of one of the actual nodes itself. So it means if one of these nodes is down, the client's not actually contacting that particular node, it's contacting the cluster IP address, and then the cluster decides, which service or from which node it can provide the service from. So we're going to keep this within our network range, so we will go for 192.168.1.60. I don't think I've got any other machines in network with that IP address. And if we click next, and hopefully this will complete without errors. Okay, so all looking good. And we should see this populate now with the details of our new cluster. Okay, so everything looks good here. We have our 2 nodes successfully added to this cluster. So the next stage is to see this actually working. So I think it's always good with these tutorials, or when you're learning something new, to actually see the results, to see it happen. It gives you a bit of satisfaction. So I thought the best way to do this was to use our client machine, and what we're going to do is I've gone ahead and I've installed the web servers role on both Clust1 and Clust2, because that's what we're going to use to demonstrate this. So on our client machine, if we, in a normal situation, if we were to contact both of the default websites on both of these servers, we would see the default IIS web page. So if we contact Clust1, it has the web servers role installed, and we should see the default IIS page. And if we put in the IP address of Clust2, we can see the same. So this proves that our client machine can contact the services, the web server service on both of these nodes. So what we want to check now, can our client machine contact the cluster itself? So if you remember, we gave the cluster an IP address of 192.168.1.60, and you can see here when we contact that address, our failover cluster is automatically choosing one of our nodes and providing this service. So let's see this working. Let's see which of these nodes the actual failover cluster is choosing for this. So if we go to Clust1 here, and if we open Paint, now bear with me, there's a point to this. We run Paint as administrator, and we open, so go to C drive and www.root, and we open the default IIS image, and let's just do something simple here. So if we give it a fill of black and save, okay, and if we go back to client, so this will be interesting. So if we refresh this, so we now have a different default IIS default website on Clust1 than Clust2. So Clust2 is just a standard blue one. Clust1 has been changed to this black one. So what we're seeing here is this is showing us that the failover cluster is actually using Clust2 to provide the web server role. And how do we know this? Because if we now go to our failover cluster manager, go to our nodes, so if we actually stop the cluster service on Clust2, so Clust2 can no longer provide the web server service to the client machine. So if we now refresh, we can see that immediately our failover cluster has automatically ensured that Clust1 can now provide that service to the client machine. So it's just a visual way of showing failover clustering in action. Okay, in the next video I'm going to look to expand on this a little bit more. I'm going to add some more nodes into our cluster, and we're going to look at configuring various different roles within failover clustering, and look a bit more in detail into Quorum and witness disk as well. Thanks for watching.